This is section 4.3, day 1, writing rules for linear functions. Our objective today is to write function rules from words, tables, and graphs. We're just going to jump straight into examples. The toll-free telephone number is $2.95 per month plus 10 cents per minute. What function rule represents the monthly cost? Our inputs are always x, our outputs are always y. So we're always going to want to write y equals. Well, what thing is happening over and over? 10 cents per minute. So we're going to have 0.10x plus we also have to pay 2.95. There is our equation. So what are the initial values? Initial, right off the bat, it costs me $2.95 to make my cost. The rate of change is the same as our slope, so that is 10 cents per minute. And how much would it cost for 105 minutes of phone conversation? So we're going to plug in x equals 105. So we're going to go y equals 0.10 times 105 plus 2.95. Well, 0.10 times 105, we just move the decimal over one spot, so we'd have 10.5 plus 2.95. So y would equal $13.45. Let's fix that. $13.45. All right, try this one. It's just like the last one. An orchestra buys music stands for $42 each, with $298 in its bank account. Write a function rule that shows how the account balance depends on the number of stands bought. What are the initial value and rate of change of the function? What would be the account balance after buying 6 music stands? All right, so for this one, our equation should be y equals, we're going to start with 298, and we're going to take away $42 for every stand. So our initial cost, or our initial amount of money, is $298, because that's what we start with. Our rate of change is negative $42 per stand. All right, and then after buying 6 music stands, we're plugging in x equals 6. So y equals 298 minus 42 times 6. Well, 42 times 6 is 252. So y equals, they'll have $46 left. All right, the table shows how the water level of a lake over time compares to its average water level. We're going to write a function rule and determine the initial value and rate of change. So using a table, since it's supposed to be a linear function, we can use any two we'd like. So I'm going to use these two. We're going to find our rate of change just like we have before. 0 to 2 is a plus 2. 10 to 7 is a minus 3. The rise over run, so we have to do negative 3 over 2. And then to find that b, that y-intercept, sometimes you'll get lucky and it'll give you 0, 10. There's my y-intercept. So my equation is y equals negative 3 over 2x plus 10, because b is 10. All right, so the initial value would be 10 inches. The rate of change is negative 3 over 2 inches per day. And there's our answer. You're going to try this one on your own. The table shows the number of inches of snow that fell during a snowstorm. Write a function rule and determine what the initial value and the rate of change are. All right, you should have started off by looking for your rate of change. 3 plus 3 makes 6. 4.5 plus 4.5 makes 9. So our rate of change is 4.5 over 3, which actually simplifies to 3 over 2. You would do this by changing it into 45 over 30, which then simplifies to 3 over 2. So now we have to figure out what our initial value would be. Because I know this is going to be y equals 3 over 2x plus something. Well, let's think about it this way. If for every plus 3, I go plus 4.5, if I do a minus 3 to get to 0, I would do a minus 4.5 and end up at 0. So we don't have to write a plus 0 on the end. We can just leave it as y equals 3 over 2x. So my initial value is 0 inches of snow, which makes sense. Our rate of change is 3 over 2 inches per hour. There's our answer. All right, Malik is a car salesman. He earns a base salary and a commission for each car he sells. So commission is like the amount of money you get in addition to your salary. The graph shows this relationship. Write a function rule. What is Malik's base salary and how much does he earn in commission for each car he sells? So we're going to determine our slope. So let's take the 2 points it gives us. It gives us 0, 10,000 and 6, 14,500. So our rise between 10,000 and 14,500 is 4,500. Our run is 6. So our slope is 4,500 over 6, which simplifies to 750. Our y-intercept is right here where we cross the y-axis at 10,000. So our equation is y equals 750x plus 10,000. His base salary is the next part. Base salary, what does he get before he gets his commission? He starts off with that $10,000. Dollar sign in there. And then we have how much does he earn in commission for each car? Well, for each car, he's going to get $750 per car. And there we are. Try this one. The graph shows the height of a snowman over time. Write a function rule and tell me the initial height of the snowman and the rate of change of his height over time. Let's find our rate of change first. We start here at 0.9, and we're going to end at 7.5.5. So you'll see that we go down, and we go down 3.5, so negative 3.5. And then we run 7. So our slope is negative 3.5 over 7, which is really negative 1/2. Our y-intercept, right there, 9. So we have y equals negative 1/2 x plus 9. Our initial height is what he started off at, time being 0, so 9 feet. And our rate of change is always our slope, so that is negative 1/2 feet per hour. And there's our answer. Your assignment is out of the textbook today.